R8, linear, compound, and absolute value inequalities. So our focus standard today is to solve linear, compound, linear, and absolute value inequalities, and we will apply them to solve application problems. So we're going to start off by just solving, graphing, and writing in set builder and interval notation. So first thing to do is to solve your inequality. Treat it just like an equation, essentially. So if I want to get t alone, I'm going to add 6 to both sides. I get negative 5t is greater than or equal to 30, and then I divide both sides by negative 5. Dividing and multiplying by a negative is a special situation where you're going to flip your inequality symbol. So I end up with t is less than or equal to negative 6 as my inequality. To graph my inequality, I make a number line. I need to make sure negative 6 shows up on that number line. I know that negative 5 would be to the right, negative 7 to the left. The less than or equal to tells me I need a filled in circle at negative 6, arrow going to the left. In set builder notation, I start my set. My variable was t, such that t is less than or equal to negative 6. And there was my rule. And then my interval notation, the furthest left I can go is negative infinity. The furthest right is negative 6. And since negative 6 was included, I use a bracket there. For this next one, I see a bunch of fractions. And to me, fractions can get a little overwhelming. So I'm going to get rid of the fractions right away. I see denominators of 2, 10, and 5. Well, the least common multiple of 2, 10, and 5 is 10. So I'm going to multiply everything by 10. When I multiply by 10, 10 over 2 simplifies to just a 5, and I have the numerator left. Minus 10 over 10 just goes away, so I will have just the numerator left. And then 10 over 5 simplifies to 2, and I have that numerator left. Now I don't have fractions anymore, and I can just distribute. So I'll distribute my 5. I get 5m minus 20. Distribute that minus, I get minus 3m minus 4. And distribute this too. Well, there's no distributing, but it becomes negative 6m. Now I'm going to combine the like terms on the left. 5m minus 3m makes 2m. And negative 20 minus 4 makes negative 24. It is greater than negative 6m. I like to move my m's onto the left, so I'm going to add 6m over. Gives me 8m minus 24 is greater than 0. Well, then I'm going to add that 24 over. And I'm going to take my work up here. I have 8m is greater than 24. And finally, divide by 8 on both sides. I get m is greater than 3. So now I'm going to make my number line. Here's 3, 4, there's 2. I need an open circle at 3, arrow going to the right. My set builder notation, my variable is m, such that m is greater than 3. And my interval notation, the smallest I can get is 3, the biggest is infinity. That was an open circle at 3, so it gets a parenthesis. Now we're going to talk compound inequalities. To solve a compound inequality, we first solve the individual inequalities. If two inequalities are joined by the word and, the solutions are the values of the variable that simultaneously satisfy each inequality. That is, we take the intersection of the individual solution sets, so where they overlap. If two inequalities are joined by the word or, the solutions are the values of the variable that satisfy either inequality. Therefore, we take the union of the individual solution sets. Let's solve some compound inequalities. We are going to still graph them, write the solution in interval notation. So for this first one, all I do is treat it like two completely separate inequalities. So I'm going to solve this first one. I multiply by 4 on each side to get rid of the 1/4, and I get y is less than negative 4. And then I solve the second one. I just subtract the 3 off both sides, and I get y is greater than or equal to 2. So my solution is y is less than negative 4, or y is greater than or equal to 2. When I go to my number line, number it here for myself. Well, y is less than negative 4 gets an open circle, arrow to the left. Y is greater than or equal to 2 gets a filled in circle at 2, arrow to the right. There's my graph. My interval notation, I'm starting, my smallest is negative infinity to negative 4 with the parenthesis. Or, that means I use my union, 2 with a bracket to positive infinity. And there's my answer. Now let's look at this next one. I have 0.36w is less than or equal to 0.54 and negative 1/2 w is greater than 3. We're going to start off by treating it as two separate inequalities. I'm going to divide both sides by 0.36. So I get w is less than or equal to, and I'm going to do this one with my calculator quick. I get 1.5. And to get rid of my negative 1/2 here, I'm going to multiply both sides by negative 2. When I multiply by a negative, I need to flip my inequality also. So I get w is less than negative 6. Since it's an and, I'm looking for where these two are going to overlap. So what they have in common. Well, they have in common anything less than negative 6. So my solution is actually w is less than negative 6. I'm going to graph my solution now. And I put an open circle at negative 6, arrow to the left. And then I write my interval notation. I start at negative infinity, I end at negative 6 with a parenthesis. And then my last one here, I don't really have space on my paper, so I'm going to do it over here. But we are going to start off with this whole thing. One option is to solve it as it is. So I look right here where my variable is. The first thing I need to get rid of is the minus 4. So I have to add 4. Well, that means I add 4 to both sides, but there's actually 3 sides. So I would add the 4 to all 3 sides of my inequality. The left side, the inside, and the right side. So that gives me negative 12 is less than or equal to negative 3y is less than 6. And then I see, oh, okay, well I have this negative 3 that I need to divide. So I do it to the right side and the left side. When I divide by a negative, I need to make sure I flip my inequalities. So I get 4 is greater than or equal to y is greater than negative 2. I don't like to write inequalities this way. I like to flip it all around. So we're going to do smallest is less than y is less than or equal to 4. Then when I graph it, I have negative 2, 0, 2, 4. I have an open circle at negative 2, filled in circle at 4, and I just need to connect them. Then my interval starts at negative 2 with a parenthesis, ends at positive 4 with a bracket. Another option for doing this one is to separate it into two inequalities right away at the beginning. So I could have made it negative 16 is less than or equal to negative 3y minus 4, and so I just took that first chunk. Then I just take the second two pieces. Negative 3y minus 4 is less than 2. You can split it apart that way. You do not have to. Either way works totally fine. You'll get the same answer. Now we're going to switch to absolute value inequalities. Remember, an absolute value is a number's distance from 0. It takes whatever we get and turns it positive. So if I have an absolute value is less than k, whatever number k is, that's the same thing as saying negative k is less than whatever's in the absolute value is less than k. That tells me that this is going to be an and situation. A less than with an absolute value is an and. A greater than is going to be your or. U is greater than k, or u is less than negative k. Notice that flipped the inequality and made a negative. And this is also true for less than or equal to and greater than or equal to. So if I have this inequality, I'm going to start off by saying, okay, well I have a less than or equal to, and according to those rules I just looked at, this is an and. So always, 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 always get the absolute value alone first, because that actually could change. So I'm going to start by acting like this absolute value is just one thing. I'm going to try to get it alone. I'm going to subtract 2 off both sides. So I have 3 times the absolute value of 5 minus x is less than or equal to 12. And then I'm going to divide by 3 to get the absolute value of 5 minus x is less than or equal to 4. Now I can see that it is for sure an and statement. Now I set up 2 inequalities. The first one is simple. I just drop the inequalities. 5 minus x is less than or equal to 4. And the second one, I drop my inequalities, or my absolute values, sorry. So 5 minus x, flip the inequality, greater than or equal to, make that 4 negative. Now we solve both of these. First step, subtract 5 from both sides. Negative x is less than or equal to negative 1. Divide both sides by negative 1. I get x, flip that inequality, get a 1. Same thing on the other one. Subtract 5 off both sides. I get negative x is greater than or equal to negative 9. Divide by negative 1. Make sure I flip my inequality. And there we have it. So I have x is greater than or equal to 1 and x is less than or equal to 9. In an and situation, I should be able to smush these into one inequality. Take my smallest number, and then I'll have a less than or equal to x is less than or equal to the bigger number. Now I put that into interval notation. My smallest number gets a bracket since it's less than or equal to. My biggest number also gets a bracket. Now let's try the second one. The very first thing I should do, solve my inequality for the absolute value piece. So I need to divide by negative 3 on both sides. That's going to flip my inequality. So I get 6 is less than the absolute value of 2y minus 4. Now those rules we just talked about only work out if the absolute value is on the left, so I'm going to flip the whole thing around. The absolute value of 2y minus 4 is greater than 6. Now I have a greater than is an or. So I write my two inequalities. The first one, I just drop the absolute value. 2y minus 4 is greater than 6. Or, second one, we drop the absolute value, so 2y minus 4. Flip the inequality and make that second side a negative. Now we solve both of them. I add 4 to both sides. I get 2y is greater than 10. Divide both sides by 2. I get y is greater than 5. Same thing on the other one. I add 4 to both sides. I get 2y is less than negative 2. Divide both sides by 2, and I get y is less than negative 1. So my solution, I like to put the less than side first. Y is less than negative 1, or y is greater than 5. When I switch to my interval, I start off, well, less than negative 1 gives me a negative infinity to negative 1 with a parenthesis. U for or, start off at 5 to positive infinity on the other side. All right, and one last one here. There's nothing to do to get the absolute value part alone. It's a less than, so that is an and. So I start by splitting it into 2. I have my first one, which is the easy one, where I just drop the absolute value and keep everything the same. And drop my absolute value, flip the inequality, and make the right side negative. Now I solve. I'm going to multiply both sides by 6. I get y plus 3 is less than 12. And then subtract 3 to get y is less than 9. Same thing on the other side. I multiply both sides by 6. Y plus 3 is greater than negative 12. Subtract 3. I get y is greater than negative 15. Since it's an and, I can smush it into one inequality. Negative 15 is less than y is less than 9. For our interval notation, we start with negative 15. We end with 9. Both get parentheses because they're not actually included. There are some special case solutions. We'll solve the inequality and write it in interval notation if we can. So notice that all of these are already solved for the absolute value part. Here I have the absolute value is less than negative 2. Before I do any solving, I need to use a little logic. Well, an absolute value is always positive. When is a positive number less than a negative? Never. There's no solution. nothing will work there. The next one, absolute value is greater than a negative number. Well, an absolute value is always positive or 0, so that's always true. This is all real numbers. Remember, you can write that as this fancy looking R, and an interval notation that is negative infinity to positive infinity. For the next one, I want my absolute value to be less than or equal to 0. Well, an absolute value can never be less than 0, so my only option is for my absolute value to be exactly equal to 0. And in that case, the absolute value symbol is doing nothing, so I'm solving x plus 1 equals 0. Well, to solve that, we just subtract 1 off each side, and we get x equals negative 1. The only time this works is when x is negative 1. One of the few times you can get an equal sign from an inequality. And this last one, x plus 1 is greater than 0. So we solve it. A greater than is an or situation. So x plus 1 is greater than 0, or x plus 1 is less than negative 0. Negative 0 doesn't exist, so just 0. We solve each of these exactly the same. Subtract 1. I get x is greater than negative 1, or x is less than negative 1. What that means is that any number works except negative 1. So I can just write x does not equal negative 1. In interval notation, I write negative infinity to negative 1, don't include negative 1, or negative 1 to positive infinity. So that's your special case when x can be anything except a certain number. All right, now we're going to do word problems. For a recent year, the monthly snowfall in inches for Chicago, Illinois for November, December, January, and February was 2, 8.4, 11.2, and 7.9 respectively. Respectively just means those went in order. So November was 2 inches, December was 8.4, on and on. How much snow would be necessary in March for Chicago to exceed its monthly average of snowfall of 7.28 inches for those 5 months? So I want the average to be exceeding, so more than, or no, just more than, sorry, 7.28. Well, to get an average, I add up everything I have. So I have 2 inches plus 8.4 plus 11.2 plus 7.9 plus the month of March. We'll call that x. And I divide by how many I had. I had 5. So I'm just going to solve this inequality. I'll combine those like terms in the numerator first. Those become 29.5 plus x divided by 5 is greater than 7.28. I solve by multiplying both sides by 5. So I get 29.5 plus x is greater than 36.4. Subtract the 29.5 off each side, and I get x is greater than 6.9. So the question was how much snow would be necessary. They would need more than 6.9 inches of snow. And there we have it. And one more word problem here. We've got Mary Lee wants to earn an A in class and needs an overall average of at least 92. Her test grades are 88, 92, 100, and 80. The average of her quizzes is 90 and counts as 1 test grade. The final exam counts as 2.5 test grades. What scores on the final exam would result in Mary Lee's overall average of 92 or greater? All right, so let's take how her grade is added. Her grade is basically all these different scores added up because she has an 88, 92, 100, and 80. Her quizzes count as a test, and then there's this 2.5 test grades. So she has 88 plus 92 plus 100 plus 80 plus 90 plus 2.5 times some mystery number. And for it to be an average, we divide by how many there are. Well, that's 1, 2, 3, 4, 5, 6, 7 and a half test grades. She wants a 92 or greater, so greater than or equal to 92. Just like the last problem, we'll combine those like terms. Oops. 88 plus 92 plus 100 plus 80 plus 90 gives me 450 plus 2.5x divided by 7.5 is greater than or equal to 92. Multiply that 7.5 on both sides. 92 times 7.5, 450 plus 2.5x is greater than or equal to 690. And then I'm going to subtract the 450 off. So 2.5x is greater than or equal to 240. Now you may be saying she can't get a 240 on her test. Correct, because we took the test grade and multiplied it by 2.5. Divide this by 2.5. Her test score needs to be greater than or equal to 96. So what scores on the final exam would result in this? 96 or higher. All right, now you'll do your assignment, and this assignment is actually changed a little bit, so make sure you double check on Google Classroom what your actual assignment problems are, but it is on page 102.